Hi, in this video I will talk about Treemap, which is this thing, which doesn't look like a tree. You might call it a map. And I will discuss what it is, how to use it, what data it supports. The origin of it is well documented. It happened not so long ago. Essentially, it is a rectangular tiling like this, and it deals with the hierarchical tree structure data. This is where tree comes from. The tree structure is easily transformed from this to this if it has a common root. But even if branches are not connected, it creates a similar set of rectangles ABC, ABC, which helps to visualize a content of a tree. That's the whole idea. For the data, it's logical to go into some biodiversity papers, and good luck, there is a biodiversity data journal online, open access, where you can read plenty of interesting stories, but for me it was a simple task to find the proper data. And I think I found it in this paper, a preliminary world checklist of fern mining insects. Let me show you a paper itself. This is the paper. It contains one big table of different kinds of flying insects, the family name, the species exactly, then the fern, it's a plant where they live on, by a geographical region and where the data are compiled from. And so that's the major content of this paper, and I want to show you what kind of illustration is used. We are close. And this is the only illustration where it tries to summarize the content of this big table. And we will try to make a tree map instead and see whether it helps to see the content of this table. That's the whole idea. Right. And so what you have to know is that we deal with the three orders of flying insects: Diptera, this kind of flies; Lepidoptera is a butterfly and moth; and Coleoptera are beetles. And fern is this sort of a plant. So I downloaded the table from this publication and did a slight change. I created an extra column order, which was in a subtitle originally, and then we can move to the RStudio. If you never did a tree map, the convenient way to begin is a graph gallery, where you choose for a tree map, and then you see these simple examples or more complicated. So you can click on any of these and see a simple script. I copy pasted one of the examples into my RStudio, installed a tree map, and here you can see how it works all together. So you need some group name, subgroup name, and the value for the subgroup, and that's all you need. Then you say tree map, where you indicate which column you take for this tree structure. I say group and subgroup, and value will be used for the making different sizes of these subgroup members and other stuff like title, font size, and so on. And here you are. That's what it makes. With this I go to my insects, check what it have, and then load the data. Is way bigger than the example. Here we have a little problem. If we compare data, which is better to label differently for our insects, with the data which we have, for example, we miss a column of values. So we have a group and subgroup. In data 1 we have this group, subgroup, and two of them we can always use, either this first and second or second and third. We still have to create a column of frequencies or numeric values, otherwise it will not go. And so I decided to take order and minor family and then count all the families all together for every order. And so I will use this simple transformation. Unique as data frame table give me frequencies for the combination of columns 1 and 2. Then you will have this table where lots of zeros are present because some combinations do not happen at any time. And therefore I take only those which are not zero. Yeah, and then we have a compact table of 3 columns, order, family and frequency, just like in an example table. With this we call a Treemap, and here we are. There is a bit of a problem with this package, that some rectangles are not named, no matter what you do, and therefore I decided to use a Plotly library as well. Plotly is a curious graphic package with a lot of different possibilities for illustrations and plenty of languages supported. The Python, R, Julia, JavaScript, ggplot, which is also R, MATLAB, F, never heard of. So you choose for R, then you ask for Treemap, and then you have a description and this nice interactive Treemap. And this is a brief example. Pay attention to this empty member of a parents, because the logics of a Treemap and Plotly is different. You don't have groups and subgroups connected in a tree structure. You have labels which include everything you use over here. And for those labels you indicate who are parents of those labels. And if you see an empty element, it means that corresponding label is a parent itself. And so I installed Plotly and copy-pasted a few examples. This probably would make sense. Nice thing is that you never miss a label, and complexity is not limited by 2 columns. You probably can use 3 or more. You can also manipulate with the colors and other stuff. And this figure is interactive. So I turn back to my data table, which is called present, order, family and frequency. And knowing that I have to add more labels than I have in my column, of minor family, I decided to not to operate with entire table but extract three independent lists out of it. So it will be labels, it will be parents and values. And if I use it as is, then nothing will happen. Why? Because I have to add those three items to the labels list, so I add it here. Then I have to add empty members to the parents. So first three are parents in cells, they don't have other parents. So it will be like this. And the same trick with the values, I have to add 3 zeros at the beginning to those parents to have all the lists equal in size. And now I can do a Treemap. And nice thing about this Treemap that you never miss the label, and it gives you the size if you point a cursor on it, and it looks nice. That's how it works. What can we learn from here? Treemaps are useful in quite colorful illustrations for the structured data from your tables. They are certainly better than table itself. It will convert branches of this structured info into the colorful rectangles, but be reasonable with the complexity and sizes, because small elements will either miss signs or the font size will be so small you will not be able to read it anyway. So readability is limited. You can probably do it in parts if the table is big, but it is certainly useful. That's more or less all what I could say for this story. Thank you, until the next time.